Good evening and welcome to the session. We will wait a couple of minutes for others to join. This is an interactive session, so please feel free to use your mic anytime you have any doubt or you want to discuss anything that will make this session more beneficial for both of us. Okay. And it might happen like last time that the network dropped and I didn't have any idea because you guys, so just let me know from where to begin again. So yeah, that will ask you to be attentive. And one more thing, are you okay? See, while presenting, I will be using PowerPoint, so it might be there might be some delay in going through chat, but okay, I will keep that in mind. So regarding the contents that have been covered till now, do you have any doubt till week 5? Week 6 we'll discuss, but till week 5, do you have any doubt or any query regarding that part? Okay. Hopefully this session will also go smoothly. Do you have a pen and paper and calculator with you? Okay, good. We'll start in a couple of minutes. Just let's see if anyone wants to join early in this case. Okay, so welcome once again to the session. The course is Introduction to Accounting and Finance for Civil Engineers. The course instructors are Professor Sudhir Mishra from IIT Kanpur and Professor K. from IIT Delhi. This live session is regarding the week 6 content. I am Vedgopal Mahajan, a research fellow at IIT Delhi. So coming to the contents, till last session we have discussed till week 5 contents, till risk analysis, Monte Carlo simulation, and we also discussed some bidding basics like definition of markup. Or so this session we will continue with those topics and move forward to bidding models. So any query regarding the previous contents that have already been covered? Okay, so moving forward with contents for this session. A contractor is bidding for a project consisting of 7 consecutive tasks. He has been provided with the BOQ. I hope you all know what bill of quantities is. His estimators have provided him with the unit cost for each task. So what we have been given is that there is a project with 7 consecutive tasks. 7 tasks you have to perform in order. He has been provided with the BOQ. So this number of units has been provided by the client. Okay. His estimators have provided him with the unit cost. This is the unit cost, that will not price, cost. He is planning to make 10% profit on the estimated cost. So overall, what is the cost for this guy? He wants to make 10% overall profit. 3 different advisors have provided him with the following bid prices for each task. So bid price for each task for 3 different advisors is given here. Numbers quite different, how to read them, we'll see. So what you have to do is you have to comment on the strategy adopted by each advisor. So looking at the values, can you see what is happening here? You have got A, B and C. Like even if you talk about task 1, it is going to cost 1000 rupees per unit. But A says that let's bid for 1100, B says let's bid for 1250, and C says let's bid for 950. Similarly, going on till task 7, where unit cost is 1500, A says let's bid for 1650, B says for 1545, and C is rising it very high till 1950. So can you see some pattern here? Can you see what is happening here? Okay, so as you can see that in case of A, what A has provided you is with 10% uniform markup for each task, right? Unit cost was 1000, so he provided with 1100, 2000, so 2200, 600, so 660 uniform for each task. Now what did B do? B loaded it on the higher side, on the earlier side, right? Sorry. So initially B increased the bid price for initial tasks, and for later tasks he even reduced it. In case of task 6, you can see that it is in negative itself. In case of C, what did he do? He increased it at the later stages, not at the front stages. So you can see that there are 3 different strategies here, or I can say loading. So what A has done is, A is uniform loading, B is front end loading, and C is back end loading. Okay, so uniform, you all can see that it is quite straightforward, just that we wanted 10% markup, so he provided with it. Now what about front end loading and back end loading? Any comment? When do you use this strategy, or what are the pros and cons of these strategies? Okay, so before moving forward, let's see what are the profits in each case. Okay, so how will you get the profit in each case? You can say that for each task, number of units n into bid price minus unit cost, right? So for each case you will get profit and profit according to each advisor. So this table comes. Okay, we know that A is uniform loading, the B is front end loading, and C is back end loading. Okay, so yeah, again some big numbers. So can you total it out? What is the sum coming for in each case? Okay. So if you see the total price, it is around 20 lakh, and profit in case of A, 10% direct markup, 2 lakh. What you can see in case of B and C also, you are getting the same value, 2 lakh each for profit. Why? Because the client itself initially told them that he's looking to make 10% profit. So you can see that the total profit is fixed, I mean same in each case, and yet the strategy is different. Why so? Well, okay. So if the tasks are to be performed in serial order, similarly the billing will also happen. I mean, if you are getting billed for not at the end of whole project but at the end of some time, maybe each milestone. So what is happening in case of A is, just a moment. In case of A, you will be getting uniform profit. In case of B, you can see that initially till task 3, task 5, even before going to last, you will get most of the profit here itself in the initial stages. In case of C, you will only get profit towards the end. Okay, now two different things. So do you want profit at the front or at the back? So as a contractor, you would be willing that, okay, let me get my profit as soon as possible. I mean, if I get the profit in the early stages itself, and towards the end if something happens, or it will improve my cash flow in ideal case also. While in back end, the contractor may think that, oh, the inflation, there is a lot of inflation. So in case of inflation, you would be willing that, okay, in task 5, 6, 7, contractor would be anyway paying me extra for the inflation cost clause. So let's make more money out of that part. So you can see that there can be both these types of loadings also. Now in India, inflation doesn't play such a big role. Okay, it is under control. I mean, we'd go on saying the term inflation, but we are okay with it. It is not to such high extents. So here you won't find contractors applying backloading, but front loading is the choice. But there are some cons also. Like, let's suppose you in task 1 itself, you are quoting 25% above the unit cost. Now if the client knows that, okay, its unit cost is around 1000 and you are quoting 1250, he might think that you are cheating him, you are taking him for a ride, 25% everywhere. So he may force you to reduce your markup for each and every item, but you know that you only did front loading, not towards the back. So bringing that 25% to some agreeable value like 15% or 10%, you will go into loss for other tasks. So yeah, this is one of the cons. For others, do think of some practical scenarios when you will use it. Okay, so now we have seen markup calculation in the last class, markup distribution in this example. So moving forward to bidding. These are some statement based questions from previous assignments. Consider the following statement in the context of statistical bidding strategy models. As far as construction industry is concerned, decision making under risk is more prevalent. As far as construction industry is concerned, decision making under certainty is more prevalent. Which of the following statement are correct? So I will give you 30 seconds or 1 minute to think about it. Okay, so any answer from your side? Which of the above statements are correct? Okay, 2 is correct, you guess. That is a bold choice. What about others? Any guess? for statement 1, statement 2. Okay, so three things were discussed: decision making under certainty, decision making under uncertainty, and decision making under risk. And as it was told in the lecture itself, that the most prominent one in construction is decision making under risk. So quite straightforward. This statement 1 is true. Uh, why? Because in case you can see that there is a lot of if you have very good, very sound estimating process where you have lots of historical data to back up, lots of experience, or the persons who are doing are expert in that field, the uncertainty quite reduces if you're taken care of a lot of variables that are there. But what about risk? Yeah, risk is always going to be there. So yeah, decision making under risk is more prevalent in construction industry, and not this case. This is not the case under uncertainty. So only statement 1 is correct. So the next question. The contractor would like to win the contract even at a loss in order to keep the production going. Second, the contractor would like to minimize the competitor's profit. Which of these statements are correct? Okay, both are correct. I'm getting one answer. Okay, so straightforward, both are correct. Now, but the thing is that contractor would like to win the contract. That is quite obvious. Why? And he would like to make profit. I mean, win contract, maximize his profit. So if we talk about maximizing his profit, why is he even willing to take a loss? Because it might happen that there are, let's say he is bidding for one project of some 200 crores and there is no such upcoming project of that range. So he knows that even if he gets that project, even at a loss, he can keep on getting his cost reimbursed, like the salary of the staff or the equipment that he had purchased already and are undergoing depreciation, so he can manage that things. So in order to keep production going, yeah, he will be willing to do that. Now what about the contractor trying to minimize the competitor's profit? So it might also happen that some other competitors are willing to bid even low. So what he would try is that he would bid low, he would reduce his own profit, so the winning bid is even lower, minimizing the other person's profit. Okay, so one more before we move on to numericals. From the viewpoint of contractor, the bidding process represents a game where he would like to win a bid at a price that gives him maximum profit. We discussed already, so I guess this is true. It is clear that the probability of winning bid decreases as a contractor tries to increase his profit margin. So these both statements are true. If you have any confusion or question, or do you want to challenge it? Okay. So I guess you all agree with these statements being true. So moving on. Now coming to the numericals. You have kept records of the bidding behavior of your competitor XY Infra. The mean and standard deviation of the company's B by TC ratio are calculated as 1.1 and 0.2 respectively. What is the possibility of winning against XY Infra in a new bid using 20% markup? Second, if the cost estimate of this new bid is rupees 1 crore, what is your expected profit at this markup? So have you guys understood the question? I would first start with, what is B by TC ratio? Please feel free to use your mics to answer. It would make things quicker. Okay, Any guess? Anything? Okay, so what we have here is that in ideal situation, we have got bid price of your competitor by estimated cost. Whose estimated cost now? Your. I mean, if it's the ideal situation, you don't know what was the estimated cost by your competitor, because you are not paying someone through back channels or just to know what their markup was. But you know that if you are in the same market, similar experiences, so you know that your estimated cost would be quite similar. Okay, so this is the ideal, in ideal situation, B by TC would be this. Now you have been given the mean and standard deviation. So what you know that this follows normal distribution. The behavior here can be represented by normal distribution curve. So first is, what is the possibility of winning against XY infra? So what you can see is that the mean is 1.1. 1.1, that means bid price is 1.1 times of estimated cost. That means he is working with 10% markup. Generally, average markup is 10%. And the standard deviation is 20%. That is quite a lot. If you know the curve is going to be quite wide, that means there is a lot of variability and you would have to cater for this uncertainty. So how do you calculate the possibility of winning against this at 20% markup? So this is normal distribution, so we will go with the curve. We know the formula, z is equal to x minus mu by sigma, right? What is x here? 20% markup, 1.2, right? Estimated cost is 1, I mean your bid price becomes 1.2 minus 1.1, that is the mu here, and sigma is 0.2. So how much does this come? 0.1 by 0.2, 0.5. Now what to do of this z? Okay, so let's try to see it in the graph. It is supposed to be mirror image on both sides, right? And this is your mean, right? And this is still 3 sigma this side, 3 sigma this side. Okay, so this is at 10%, 1.1 or 10% I will say, but you are bidding at 20%, somewhere around here. So you can say that area under this curve till this point will give you the chances that he is bidding lesser than you, and this remaining will be where you win, right? Is this clear, or shall I repeat? Okay, so in this case what you have got is, you have got z value. How to use it? You have been given z is equal to 0.5. This is the table, standard normal distribution. Table values represent area to the left of z score, right? This is the left word. So how do you read it? You have got till 2 decimals, 0.5 and 00. So area is how much? 0.69146. So what is the probability of winning? If the total area is 1, so 1 minus area towards the right, right? So how much is it? Okay, somewhere around 31, right? So 31% probability of winning. Agreed? Or any confusion in this part? We will be following this template for all the numericals that we are going to solve today. So any confusion in this? Okay, no confusion. So for the first, you have got your answer as 31%. Okay. What about second? If the cost estimate for this new bid is rupees 1 crore, your total cost is 1 crore, what is the expected profit at this markup? Now the question arises, if we have been told that our markup is 20%, so our profit should be 20% of the cost, right? No. Why? Because there is some probability attached here, and we know that in case of probability, your expected value is P into the value you wanted, right? Expected profit. So how much it would be? P into profit. 0.31 into your profit is, your project cost is 1 CR, right? So let's write as 100 like into 20% markup, right? So how much does this become? 0.31 into, so this becomes as 6.2 lakh. So are you okay with these values? Six 6.2, yeah. Okay, any confusion in this part till now? I will need your response. You guys can hear me and see my screen clearly, right? Anybody? Okay, so moving on. Now in previous case you were given mu and sigma. What is happening here? Contractor X is developing his bidding strategy against contractor Y. So only one competitor again. The details of B by TC ratio is given for 15 bids now, in which contractor X has competed against contractor Y. Why is this line important? Because only because they competed, in those cases only contractor X would have calculated the estimated cost for him, right? Would have estimated the cost. Otherwise, if there is some project where only contractor Y is bidding, he is not interested, so he won't be calculating those costs and not be calculating B by TC ratio. So you have been given, now it is assumed that the markup is expressed in terms of some percent of the total cost. So some percent of total cost, then you can see that for 0% profit, B by TC is equal to 1. So if it is assumed that markup, based on the bidding behavior, what's the markup percent that contractor Y uses on an average? So contractor Y uses on an average, this becomes the question of calculating mean in this case, right? Any doubt about the question? Okay, I will give you guys 1 minute to read the question if you want. Okay, let's start solving. So B by TC ratio is given and markup is expressed in terms of total cost. So in this case, markup is minus 0.2, 0, 2, 4. I mean markup is in terms of, if I go with by percent, okay, I will talk in terms of percent. So this becomes minus 2%, right? In each case 6, 8, 12, 16 and 20. How many times the numbers have been given to you, right? So n into markup percent by sigma n becomes your, what is it? This becomes your mu, right? Mean. So can you guys calculate it? Like you just have to go by 1 into minus 2, 1 into 0, 2 into 2, 2 into 4, 1 into 6, 4 into 8. Let's do it. Minus 2, 0, 4, 8, 6, 4 into 8, right? Yeah, 32, 12, 32 and 20. And what is the total number of bits? We have been given 15. So how much does it come? 20, 20, 40, 40 and 10, 50, 50 and 64 or 62 I should say, right? 112. So 112 by 15, that your comes out to be 7.4, 7.5. So 7.467, right? This is the mu. You guys check the calculations once. The step is clear to you guys, right? Okay. So what is the next part? If X uses a markup of 12%, what is the probability of winning against the contractor Y? If the estimated cost is rupees 10 lakh, what are the expected profits for contractor X? We did a similar case, right? Just in the previous question, but what you can see is that you haven't been provided with sigma. So how do you calculate sigma? Sigma is equal to under root x minus mu square by n minus 1, right? This is the formula. And if you guys have scientific calculator in your hand, you can just directly calculate it. I'll be doing the same using my calculator. Yeah, so what is the sigma value you are getting? I am getting it as 6.3, 6.3%. So for the next question where you have got 12%, okay, your Z value becomes 12 minus your mean is 7.467, right? By 6.3, that comes out to be 0.72. So for 0.72, if we read this table, how much value are you getting? For 0.72, it is this one, 0.764, but 0.764 on the left side, right? So your probability of winning becomes 1 minus 0.764. Is this correct? So what are your expected profits now? Expected profits is equal to 0.236 into 12% of 10 lakh, right? So this becomes rupees 28,300 something, right? So any question till now? For one competitor, what we did, how we calculated the probability using normal distribution. Any question till now? Or should we move forward? Okay, so I've got one. Okay, let's see what is happening. You have got you are in a competition with one competitor. Okay, contractor Y. So now you have been in the market for a long time, so you know that your estimated cost would be the same, right? You would be using similar buying things from the similar sellers, similar subcontractors working under you, similar team, similar management. So you know that okay, what is going to be your expected cost, and you believe that it is going to be quite similar for both of you. Now from his previous bids, that is quite open after the tender, you know that okay, how much is he bidding. So you know that you made the histogram of this. So you know that in first case 0.98, when his B by TC ratio was 0.98. What is 0.98 now? If you are expressing your markup as some percent of your total cost, you can say that he bid at -2% of the estimated cost one time. In one case, he bid in such a scenario where no profit, no loss. 2 times he bid for 2% profit, 2 times he bid for 4% profit, and similarly for 15 projects you have the data. Now what do you want is that you want to calculate his average, that okay, he keeps this value in mind and he put some his average markup is this value. So how do you calculate it? You have been given the values and their weights, right? So you calculated the average markup, that is the mean in this case, 7.467. Now what is the deviation, or what is the spread of this mean? And that you calculated using the formula for sigma. Now you know that his mean is 7.467 and his sigma is 6.3. Then in the next project, you are interested in using the markup of 12%. 12% is quite a high value, right, in the competitive environment. So you want to know what is your probability that contractor Y would bid more than that. In only that case you will win, right? So what you can plot from the previous data is, or what you have already plotted is, the normal distribution curve. I don't know why I make it as a beta curve. Okay, just assume that this is symmetrical on both sides, where mu is some value and that is sigma, the spread. Okay, so for 12%, you can see that 12% is coming somewhere here. Now this is the probability where contractor Y has bid less than 12%. So only if he bids more than 12%, you are going to win. So you calculate the area of this part. How? You calculate the Z value. For that Z, you calculate the probability of winning. So your probability of winning becomes 23%, 23.6%. Now for this case, your expected profits, so your profit should be 12% of 10 lakh, right? That means 1.2 lakh. But you have now studied probability and the value, how to calculate expected values. So multiply this with the probability that you have into P, 23.6%, you get your expected profit. Okay, is it clear now? Okay, so moving forward, now this situation, you saw how to deal with one competitor only, but in the market there may be a lot of competitors, at least a handful of them, even eligible ones. In civil, in construction line, you know that there is very low barrier of entry. Like anybody with some amount or who wants just to enter in the market, he can very easily enter. But staying in market is quite tough. So yeah, there are a lot of competitors. Now, how do you calculate the probability in that case? You saw how to calculate it in for one competitor, right? Now, Friedman, he's known as the father of bidding strategy in our case. Why? Because he was the first one to attach all these things, the probabilities, the variables, multiple probabilities. In this case, gamification of bidding. So, how to do it for multiple contractors or multiple competitors? So here you can see that there are two cases where you know all your competitors, or where you don't know your competitors but you know something about their behavior. I mean, the behavior is going to be general, right? So in case that you know their you know your competitors, Friedman model gives you the probability of winning as your probability of beating A into probability of beating B into probability of beating, and this is not the beating, this is like winning against beating. You are not directly going to incite violence, just winning against them. Okay, so just multiplicative probability and so on. Okay, so if your probability of beating each competitor was 0.5, I mean 50% of times you are beating it from your histogram at some markup, you can know that if you increase your markup, your probability of winning will reduce. So let's say for 10% markup, you were winning 50% times in each case against each competitor. So your probability of winning becomes 0.5 into 0.5 into 0.5 into 0.5, right? If you have 4 competitors, that is like 6.25% only. Okay, so similarly, when you don't know your competitors but you know the typical behavior, okay, so in that case your P becomes probability of winning against a typical contractor to the power n. If you have got n competitors, the number of competitors you have to guess. I mean, if it's n, you'll be working. Okay, so this is a model. Now we gave just the example we took, 50% probability of winning against each competitor. So that means in that case you would have said that if there are 5 players in the market and 50% probability of winning against each, then you should have at least, I mean, you logically thinking, it would have been, your probability of winning should have been 20%, right? 1 in 5 chance for everybody. But Friedman is giving you the value of 6.25% only. So yeah, this theory, everybody liked it. I mean, this pioneered some new thoughts, but it was not that accepted. It has a lot of criticism. So many models came, and this person, Gate, was one of the, you can say, biggest critics of this model. And he not only criticized it, he also gave his own model. So you can see the formula in front of you for known competitors and unknown competitors. Any question regarding these basics or these formulas? Now also you know how to calculate probability of winning against one competitor using normal distribution, right? Okay, so moving forward, this is the part of the same question that we were dealing in a new project with rupees 50 lakh estimated cost. Now your estimated cost is 50 lakh. What will be the optimum markup percent that contractor X should use if it is foreseen that 4 typical contractors similar to contractor Y are in the field? Use Friedman's model. So what you have been given is that the distribution you have in front of you is for the typical contractors, right? And how many are there? 4 are there. So can you tell me how to proceed now? You have to determine the optimum markup percent. So my first question to you guys is, what is optimum markup percent? And the second is how to proceed. Anybody? Guys, please use your mic so I know that you are present. The question is, what is optimum markup percent? And if you understand that and you don't want to respond to it, then help me to proceed for this question. How do I do this? How do I solve this? Anybody? Anything would be a right answer to start with right now. See, I've got time till 8. I'm sitting here for you guys only. This is basically for your benefit, and the least I expect is some responses. You are also giving your time here sitting in the live session, so for your own benefit, do try to participate. Okay, so we are talking about some optimum value. Now, if it was just a competition, like you have to win at any cost, you could say that this contractor doesn't bid below -2%, right? So if you are bidding somewhere around -4%, you will always win your bid, right? He is not bidding below this part. But are you interested in this? Or maximum times you would win at negative or very low values. At -10%, you are 100% sure that you will be winning the bid. But what about your profit in this case? You will start going into losses, right? Very soon. And if it were the case that you really need to win this project, you need to keep your equipment, your manpower engaged somehow, you need to move on with this, you would be okay with it, that okay, I will deal with the losses also. But when we are talking about the competition and ideal scenarios, you not only want to win, but you want to win at and maximize your profit. Now, maximizing this profit comes at the cost of your mental exercise. Like, let's suppose that you are bidding at you want 3% profit, you are bidding at 3% markup, and your competitor is bidding at greater than 3% markup. Okay, in this case you will win, right? So if this were the case, you know that you are winning at 3%, 50 lakh, so it gives you your profit as 1.5 lakh in case of one contractor only. Or if there are n contractors and you are winning it at 3%, your direct profit would have been 1.5 lakh. You are happy with this, but you don't know what is going to happen. You have some probability distribution you want to determine. Okay, so what you do is you check for each percent, or you check for each value of markup, that if I let's say that you are working with 1% markup and your probability of winning is 80%. So 80% of time you will be getting 1% markup. If you're bidding at 2% and your probability of winning is 75%, at 3% markup, your probability of winning is 60%. At 4% markup, your probability of winning is 50%. At 5% markup, your probability of winning is 25%. And at 6% markup, your probability of winning is 10%. I mean, these are some random values, right? Let's keep it as 20. So do you agree with this trend that if you go on increasing your markup, your probability of winning will decrease? Do you agree or not? Okay, so in this case, if your amount would have been 100 rupees only, your cost, so profits would have been, in this case, let's keep it as, okay, 10,000. In this case, 1%, your profit would have been 100 rupees, 200 rupees, 300, and so on. You're right. But you have been given, you have attached some probabilities in this case. So expected values, you will say 100 into 80% chance of winning, right? So it would have been 80, 200 into 75, 150. You can see that your expected value increased somewhat. 300 into 60%, 180, 400 into 50%, 200, 500 into 20%, 100, 600 into 10%, 60. So can you see some trend happening here? That if you plot this, your values are first increasing 80, 150, 180, 200, then okay, 200, dropping to 100 and 60, right? So you know that if you bid somewhere for this value where you are getting higher higher expected value, 5%, so you will be happy that your profits are also high and expected value is also high. So do you get this concept, what we are looking at? This is just one random example where we saw what happens, what kind of trend we get. So you saw that with increase in markup, your probability of winning decreases, and but it is not the same for your expected profit. I'm not talking about only about profits, but expected profit, probability of winning into the profit. So expected profit do follow a curve. So your optimum would be somewhere around the peak of this curve, right? Does everybody agree? Anybody? Do you agree? What is happening here? What happened? Okay, so now coming back to our question, what is happening is that we don't know this value, right? We know that, okay, we can go on increasing our markup by 1% or by some value, some small value. We know that our estimated cost is 50 lakh, so we can calculate the profit for that markup. But what we don't know is the probability of winning for that markup, right? So this part we have to calculate. And how do we calculate? We again go back to our standard deviation table. We calculate normal distribution, sorry. We calculate the Z values and we calculate probability in each case. Okay, so let's try. This is the table we already have. This is just okay, anybody who would like to come up with the steps now? You already saw the example, what is happening. So how to do it? Just like, you know now that the only missing part is that we want to calculate the probability of winning. How to do that? You already, the model is given to you that you have to follow Friedman's model. What else do you need now? Okay, so we will start that. Your markup is 1%. For 1% markup, and what is your mu and sigma? Mu is 7.467, right? If you remember what we calculated, and sigma is 6.3. So for 1% markup, your Z becomes 1 minus 7.467 by 6.3, right? And this comes out to be 6.46 minus 6.467 by 6.3, 1.03 in negative. For 1.03 in negative, in positive, what value we are getting? 1.03. This is the value we are getting. Okay, 0.8489. So P typical, and as it is negative, we don't need to subtract do any operation. 0.8489. And why I'm not doing it, you guys have to answer it. Okay, I mean, in previous cases we were subtracting, but in this case I'm just writing it. Okay, so P typical is this. So P winning, what would it be? It would be 0.8489 to the power 4, because we have got four such, right? 4 such contractors. So it becomes 0.5183. And so expected value is 1% of 50 lakh, right? Into P of winning. What is the value now? 25915. Do you guys follow this calculation? What is happening here? We took 1% markup, we calculated the Z value, then typical winning probability for a typical contractor, one typical contractor. For Friedman, we applied some formula and got some values. Okay, just anybody. I mean, any confusion? Are you happy with this? Okay, so moving forward, let's try this for 2% markup. You guys should calculate these values. So at for 2%, 2 minus mu by sigma, how much is it coming? It comes around minus 0.87. So minus 0.87, so P typical comes out to be minus 0.87 is this value, right? 0.80, 0.80785. So P win is equal to P typical to the power 4, right? Point 4259. So if this is your P win, your expected profit becomes 2% of 50 lakh into P, right? Mm. 42590, right? So you can see that from 1% it was around 26,000. For 2% your expected profit increased to 42,500. Now for 3%, let's calculate the same. For 3%, z is equal to 3 minus mu by sigma, and that comes out to be minus 0.71, right? So P winning against a typical for minus 0.71 becomes 0.76115. So P win becomes this into power 4, right? To the power 4, and that value is 0.33564. So expected profit in this case is equal to P win into 3% of 50 lakh, right? Rupees 50,000, yeah, 346. So, and did any of you guys calculate this with me? Can you guys cross check if this is the right value or not? Okay, one question: are these markup values randomly generated or calculated? So what we are doing is that we are assuming it, like we are not generating it randomly, or we are not calculating it. We are going in some manner. Like let's suppose that I target 1% profit. So what is my expected profit? Let's suppose I target 2% profit. So that is how I'm calculating. Just getting the values, what we did in this case, as you can see, we tried to plot the curve, right? For 1 to 6%, and we got some optimum value. So what we are trying to do is we are trying to do the same for the given question. Does this answer your question? Okay, so coming back, we did it for 1%, we did it for 2 and 3%. Now what can you deduce from these calculations till now? you can say that your expected value is increasing with increase in markup. So you are happy on both sides. Your profit percent is also increasing, expected value is also increasing. Let's see what happens next. Okay, so at 4%, what is your Z value? It comes up to be minus 0.55. Okay, for this your P typical is for 0.55, it is 0.70884. So your P win is P typical into power 4, right? So this becomes 0.25246, right? 25246. So your expected value now is this P win into 4% of 50 lakh. And how much is this? Rupees 50,492. Let's see, is it increasing from 3%? Yes, it was 50,350 and this is 50,500. Okay, so the value has increased again. What to do next? We will increase our markup again. So for 5%, let's calculate it. For 5%, our Z is minus 0.39. For 0.39, the value we have is 0.65173, right? Yeah. So P typical is 0.65173. Your P win becomes, the formula is same, 0.180414. So your expected value is yeah, this comes out to be rupees 45,100. Okay, so what happened now? You can see that from coming from 4% to 5%, your value decreased, right? So what would be the answer in this case? Now you can see that there is some curve, right? From 1%, 2%, 3%, 4%. At 4% it is peaking and then again reducing, coming down towards 5%. So what would be your answer? We saw the optimum curve, right? We saw the curve, we saw how to determine the optimum point. So with these 5 points only, you would say that the best point for us is, let's keep markup as 4%, where expected value is 50,500, right? Higher of each. So is this your answer? I mean, will you stop here? Just say that your answer is 4%. Let me go back and write here, okay, that your answer is coming to be 4%. Are you happy with this? See, your amount is so big. I mean, 50 lakh, 4% of 50 lakh is how much? It's 2 lakh, right? I mean, anybody, it's basic calculation. I will need your responses. So, can there be some value where at 4.5% also you could have gotten some value? I mean, you don't need to have such rounding of numbers while deciding your bid price, right? And even in cases where you have to give the percentage of some BOQ or some SOR, your values are generally not rounded off. You get the values, bit values like 5.67% or even minus 18.82% in some cases. So what you do again is that you don't stop here and you try to increase your markup by some small values, zero point 0.2, 0.3 in each direction, and try to find out what is the optimum point. Is this point clear? Is this point clear what we did? So what we did was okay. So we did it for 1%, 2%, 3%, 4 and 5, and we got some curve and we stopped at 4%. Now that was the Friedman's model. Sorry. So now how to do it with Gates model? What will change in this case? You guys need to answer this part. The type of model is changing, so what will change in further question in our calculations part or in our thought process, how we are going to approach the problem now? Anybody? Okay, so I guess I will have to move forward with this. So what is happening in this case is we have got Gates model. Rest of the things remaining same. You just have to find out P win in each case. Right, so let's move towards this. For 1% markup, what we have already calculated is we have calculated Z value, we have calculated P typical, right? Till this the values will remain same, don't you think so? I mean, Z value is the same, P typical for one contractor, it won't change, right? It would still be 0.8489. Now P winning in this case will change. Anybody, you can give me the formula now? We have got n is equal to 4. Okay, so let's do one thing. Let's visit the formulas again. So Friedman's model and Gates model, you see that till winning probability things are same for single contractor or for against single competitor. The only change is that winning probability considering multiple competitors, your formula is changing. So in known case you have got P winning is equal to 1 upon 1 minus PA by PA for each plus 1. And for unknowns, this is unknown case. So P is equal to 1 upon n into 1 minus P typical by P typical plus 1. So let's try to apply this formula. Okay. So the formula here becomes 1 upon 4 times, because your n is 4, 1 minus 0.8489 by 0.8489 plus 1, right? This is the formula. So what is the value you are getting? Okay, so this value is coming out to be 0.5833, right? So your expected value now becomes 0.5833 into 0.5 lakh, I mean 1% of 50 lakh, right? And this comes out to be rupees 29,000. Similarly, if you do it for 2%, P typical we calculated previously. Let me check what value were we getting. Okay, for 2% single you are getting 0.80785. Now P winning is equal to, let me repeat the formula for you guys, N is 4, so 1 minus P typical by winning against typical plus 1, and in this case it's equal to how much value are you getting? Are you guys calculating with me? Okay, so this comes around 0.5124. So your expected value becomes 51,000. See what is happening in this case. I mean, if I go back to our Friedman's model, for 1% our expected value was 25,000, our winning probability was 51%. For 2% our winning probability was 42% only. Expected profit also reduced. I mean, expected profit is a function of winning probability, so we'll just focus on winning probability. You see that winning probability in case of Getz model we are getting on the higher side, right? Can you guys see this point? Because this will help you in some statement based questions, and obviously in understanding these models a little better. Okay, so moving forward, 1%, 2%, next would be doing it for 3%, right? Z value and P typical remains the same. So going back to check the P typical, and the value is for 3% it is 0.76115. So P winning is equal to 1 upon 4 into 1 minus P typical by P typical plus 1. So this comes out to be 0.4434. So your expected profit becomes 0.4434 into 3% of 50 lakh, and that value is somewhere around 66,500. Now you can see that again your value has increased from 2 to 3%. Let's do it for 4%. Okay, going back to check the value of P typical. Yeah, it was 0.70884. Calculating the probability of winning by Gates model. .37835. So expected profit rupees 75,700. Again your margin has increased, your expected profit has increased, you are happy. Now what? Moving to the next value. Check for 5%. 5% P typical was 0.6516 0.65173. So P winning in this case becomes 0.3187, right? So again your expected value is this into 5% of 50 lakh. Rupees 79680. Okay, so 4% was 75,700, 5% 79,680, somewhere close but still increasing. Let's check for 6%. 6% we don't have P typical, so we'll go by Z again. Z is equal to 6 minus 7.467 was our mu and 6.3 was our sigma, right? So this comes out to be minus 0.23. For minus 0.23, checking the value, yeah, 0.59095, right? So P typical is equal to 0.59095. So P win by Gates model. How much are we getting for 4 competitors? Taking this value, yeah, it is coming out to be 0.26534. So your expected value now is multiplying this into 6% of 50 lakh. How much is it? Okay, coming quite close. 7960. Yeah. So you guys follow till here. What is happening now? The value reduces at 6% now. So you would say in case of Gates model, the answer you are getting is 5%, right? Obviously solving it by computer, and if your answer is not in single digits, you will have to solve for getting the better answer, getting the better value. Any question, any problem till here? Any question? Is it all clear till now? I mean, we solved Gates and by Friedman model and Gates model for typical known number of typical competitors. I mean, we didn't know the competitors, but we knew how many were there. Okay, so we also saw the curve, some values like via Gates model we are getting some higher markup, so some higher value of return. So this question is moving to the next question. Contractor keep records of his 3 competitor companies. Now you have got 3 companies and mean and standard deviation is given to you. That means these are known to you and you have to use both the models. So before that, let's move on to some statement based questions. Consider the following statements in the context of statistical bidding strategy models. Statistical bidding strategy, right? We are using statistics, previous history. So statement 1, Friedman's model in most cases determines lower optimum markup than that of Gates model. Yes, we saw that. I mean, it was giving answer 4% while Gates was giving 5%. Second, Friedman's model is more optimistic as it assumes that one can still win the bid at high markup. This is quite contradictory, right? I mean, it is not optimistic but a pessimistic model. So you can say that statement 1 is correct but statement 2 is wrong. So one more statement type question. I will give you 1 minute to read it, and if you would like to answer this. Statement 1, Gates model uses power relationship to calculate the probability of winning against a number of unknown competitors. Second, Friedman's model uses power relationship to calculate the probability of winning against a number of unknown competitors. So the only thing changing is that which of the models is using power relationship. So only one of them can be true. So you know that in Friedman's model we were doing for P winning is equal to for n competitors we were doing P winning is equal to P typical to the power n. So power relationship was used in Friedman's model and not in Gates' model, right? So this is statement 1 is wrong, but statement 2 is correct. Okay, so coming back to our numerical, so just taking a break for a moment. Do you have any doubt, any query till now? Anything that you would like to discuss? Anything that you would like me to shed more light on? Okay, so is this question clear to you? I mean, what is happening? Okay, if this is clear, I will just follow this with the steps to solve it, and we won't go into solving it. Okay. I mean, is that okay with you? Okay, so in this question what you have got is you have got three competitors A, B and C. Their mu and sigma is given to you, so you can make the normal deviation and normal distribution curve for these. So what is the probability of winning the bid against these three companies at markup of 6%? So markup of 6%, that means that what you have to calculate first is that your probability of winning would be probability of winning against A into probability of winning against B into probability of winning against C, right? In case of A, for first question, that would be your answer. Now how to calculate PA? You have been given these values, right? 1.08, so 1.08 is B by TC, so you can say that it is 8% and 5%, right? If I don't want to go into the values given, I mean I want to talk in terms of bigger values, right? So if I take this forward for PA at 6%, right? So my Z would be 6 minus 8 by 5. Agreed? So minus 0.4. For minus 0.4, what value are you getting? You are getting is equal to 0.65542. Right? In case of PB, Z is equal to 6 minus 4 by your standard deviation is 4, right? So you are getting it as 0.5. So for 0.5 your PB becomes 0.69146, right? Or am I doing it wrong? Will it be these values or there would be some change in case of PB? Because this point you will get only after imagining the normal distribution curve. See, previously it was minus 0.4, okay? so that's why we took the value as it is. This was minus, right? In this case, PB would be 1 minus this value, right? So you can write it as 0.31, just rounding up for you now. And in case of probability of winning against C, your Z would be 6 minus 10, it was 1.1, right? By 7. See here, this is 1.1, so 10%, and this becomes your 7%. So your Z value becomes 0.5714, 5.57 we can see, 0.5 and 0.07, this becomes 0.7156, and this is again negative. So PC becomes 0.7156. Okay, did you follow till here? What happened? Okay, so now coming to our question, we knew how to calculate it for gates, right? For gates we had this formula for A case, right? So let's try it. I mean, this becomes 0.655 into 0.691 into 0.7156. How much is it coming? Into 0.691, 0.7156. So your probability of winning is coming around 32.39% in case of Gates model. In case of Friedman's model, right? Just power relationship. In next case, it would be 1 upon 1 minus PA by PA plus 1 minus PB by PB plus 1 minus probability of winning against C by PC plus 1, right? So how much is your P win coming in this case? Okay, so this is how you proceed with B. Now what about C? How do you do it? We saw how to do it in case of n type of unknown when with probability of typical. So similarly you have to proceed for C, like just keep your markup increasing by 1%, and for each you calculate PA, PB and PC for each markup, determine the P winning by each model. No, in this case you have been given that you have to follow only Friedman's model, right? So all you need to do is you have to calculate it by Friedman's model, multiply the probabilities and get P winning, and to determine optimum markup you have to multiply it by your margin and the estimated cost of rupees 10 crores, and you will get your expected profit. So any question till the bidding part? With this we finish our bidding. Yeah, so these were some statement based questions that we discussed. So with this I am ending the session here. Thank you for attending. Thank you for listening. If you have any doubts or you would like to reach out to me, please feel free to write. See you in the next session. Thank you.